Okay. One of the first steps in the development of molecular therapeutics often involves the identification of promising bioactive molecules. Researchers can then perform trial and error experiments on that molecule, modifying functional groups and observing what effect that has on its actions. Through this, they hope to identify even better derivatives of that same molecule. One such molecule is the class of chalcones. So a chalcone consists of two aromatic rings connected by a bridge. One has we've used 3 different chalcones in our experiments. One has a dimethoxy substitution on the first ring, one has it on the second ring, and the third has it on both rings. Now, a few recent papers have motivated this study. One identified one of our chalcones as lifespan extending in a small roundworm called C. elegans. This was actually contradicted by another paper. And then a third paper found that one of our chalcones was capable of enhancing the action of a cancer drug on cancer cells, while at the same time reducing its action on healthy cells. This action was found to be at least in part due to activation of a specific transcription factor, one that we're going to refer back to in a second. So the first assay we did was a lifespan assay. We observed all 3 molecules to be quite cytotoxic, resulting in death of the worms in approximately 25% of the control's lifespan. We also found that the substitution on the second ring was significantly enhancing this toxicity. In the second assay we did, we looked at the activation of the SKN1 transcription factor, which is actually a worm homologue of the one mentioned earlier. We used a strain of worms that produces this protein with a green fluorescent tag on it, and we looked at where that protein localized. We observed that all 3 of our chalcones result in activation of this pathway quite significantly. However, the substitution on the second ring actually decreased this activation. So in conclusion, through our 2 experiments, we have evidence that altering dimethoxy substitution patterns on chalcones alters their effects in C. elegans. Thank you.